Hello, dear aspirants. This is Dr. Sourav Sir's classes. Our contact number is 98367 93076. Again, I am repeating our contact number, which is 98367 93076, and our email ID is sourceclasses@gmail.com. So if you have any mathematical queries, that means you can have any doubts or anything, so please feel free to contact us. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID, then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes, so that will be beneficial for your preparation of upcoming examinations. Okay, like ISI CMI entrance test, or rather CSI and NET gate, etc. So please feel free to contact if you need any help from us. So now we are going to solve a problem which is appeared in the ISI JRF question paper, and the question is telling us that let D belongs to the open disk. That means Z belongs to C, mod Z less than 1. Prove that there is no continuous function on D bar such that f is holomorphic on D and f of Z equals to Z bar for all Z belongs to del D. Okay, so let us see what can we do. So, okay, so to prove that there is no continuous function f on the closed unit disk, which is that is Z belongs to C and mod Z less than equals to 1. That is holomorphic on the open unit disk, which is D equals to Z belongs to C mod Z less than 1. Okay, fine. And satisfies f Z equals to Z bar for all Z on the boundary, which is del D, that is equals to Z belongs to C mod Z equals to 1. We want to proceed via contradiction. Okay, so assume such a function exists. So suppose there exists a function, there exists a function f, and that is continuous on D bar holomorphic on D and satisfies fz equals to Z bar for all Z belongs to del D. Okay. So now we are going to analyze the boundary condition. So on the boundary del D, our mod Z is equals to what? Our mod Z is equals to 1. So our Z into Z bar is equals to 1, which implies that Z bar is equals to 1 by Z. Thus the boundary condition becomes f of Z is equals to 1 by Z for Z belongs to del D. So fine, so good. Now we are going to apply the maximum modulo principle. So the function f is holomorphic on D and continuous on D bar by the maximum modulus principle. The maximum of mod of fz will be the maximum of this on D bar must occur on the boundary del D. So on del D, our mod of fz equals to mod of 1 by Z, which is equals to 1. Therefore, our mod of fz is less than equals to 1 for all Z belongs to D bar. Okay. So now we are going to consider the function which is g of Z equals to ZFZ. Okay. So then our G is holomorphic on D, since F is holomorphic and Z is also holomorphic. G is continuous on D bar, and on the boundary del D, our G of Z is equals to Z. So, our G of Z is, that will be now z into 1 by z, so that will be 1. Okay, so by the maximum modulus principle, our mod of gz attains its maximum on del d, where our mod of gz is equals to 1. Thus, we can say that mod of gz less than equals to 1 for all z belongs to d bar. Now, but we know that our gz is equals to 1 on del d. So, we can say that our gz is equivalent to 1 on d bar by the identity theorem, since our g is holomorphic and constant on the boundary. Okay, so now derive a contradiction. So, if our gz is, okay, let us write with another color. So, if our gz is 1, then our f of z will be 1 by z for all z belongs to d. Okay. So now, but suppose, but our f is supposed to be holomorphic on d, and we can say that our 1 by z is not holomorphic at z equals to 0, because we can say that it has a pole on that point. So this contradicts the assumption that f is holomorphic on d. So the final conclusion of this question will be drawn to that there is no such function exist which satisfies all the things. So yeah, so now we can say QED. Okay. So hope you understood, guys. Again, I am telling that if you have any other mathematical queries, doubts, or anything, or if you have any or any other doubts or any other subject doubts, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange it out clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay. Hope you understood, guys. Thank you. So please let us know if you need any other help from us. Okay, thank you. Hope you understood. Thank you.